Good afternoon and welcome to Cutting Tool Engineering's Ask the Experts webinar on Indexable Inserts. My name is Dennis Spaeth, the owner and publisher of Cutting Tool Engineering, and I want to thank each of you for taking an hour out of your day to attend today's webinar. I will be serving as webinar moderator for today's event as well. Now let me introduce you to today's expert panelist, Robert Bokram, the product manager, Ceratizit Cutting Tools. Welcome, Rob.
Thank you, Dennis, and thank you for the opportunity to talk to your audience about some of the new technologies that are available to the manufacturer.
As moderator, I'll be asking Rob to answer a series of pre-arranged questions to get things moving. Following this portion of the webinar, we'll open things up to take questions from the general audience. Now let's get started. Since we're going to be discussing positive negative inserts today, Rob, can you give everyone a quick overview of these double-sided inserts?
Today, we want to talk about pos-neg milling systems and the double negative inserts, which are inherent in their design. And as they say, a picture is worth 1,000 words. So I thought we would start out with a video of a 90-degree style pos-neg design performing several different operations. So let's talk about some of the features and benefits of this pos-neg design. First of all, and right up front, the most significant advantage for the customer is that you double the number of edges and you cut your cost per edge in half. Beyond that, you have to look at the design itself. The cutter has a negative axial pocket and a positive radial angle, and so you have what we call a pos-neg design. That negative axial angle actually helps to balance the forces between the spindle and the cutter. Many positive designs have a tendency to want to lift the workpiece. Here with this pos-neg design, it helps to mitigate that differential in the forces. It helps to balance the forces. Additionally, you have a very stable cutting edge because you have a negative clearance angle, which allows that insert to be well supported in the pocket. This allows you to take higher feed rates, run at higher speeds, and gives you a chance to take higher depths of cut as well. So all in all, it's a very robust design, very stable, and able to machine almost all materials, typically not aluminum, although there are some designs that can. The interesting benefit as well is when you have a negative design like this, you have a more stable cutting edge because you don't need as high a rake angle to because the insert is pitched negatively in the pocket.
Okay, Rob, so what are some of the suitable applications for these double-sided high feed inserts?
So typically these high feed inserts, these double negative high feed milling system designs are capable of machining most all materials, typically not aluminum and not hard materials, but every other material type is an eligible candidate. So when you're using double-sided technology, there are some constraints. For example, you're not going to be able to ramp or plunge or helical plunge. So these cutter systems are restricted to face milling or long reach face milling. Secondly, these cutter systems are, especially the high feed systems, are not meant to be finishing cutters because they don't leave a very good finish. So you're really talking about medium machining and roughing. Finally, you do have some restrictions on the materials you can machine. Typically, you don't see these cutter systems being applied to non-ferrous materials or hardened materials. So you have to take a look at what operations are required to machine your part because there are some restrictions that you will have to consider.
As more shops turn to toolmakers for production improvements and guidance, what might be your top recommendations, particularly for shops only getting 60% to 80% of the life expectancy out of these inserts?
Yeah, I think that's an interesting question because historically, some of these original designs were made to sort of conventional dimensions, and operators were very concerned about the fact that the wear scar was impinging on the opposite edge. So they were concerned about the inability to use all the edges of the insert. More recently, there have been developments by a number of manufacturers where they've decided that it makes much more sense to build a thicker insert so that the wear scar has plenty of room, if you will, to wear, and still all the edges will be available for use. In our case, we have taken a different approach. We have built in a clearance angle on all the edges to the center line of the clearance face. This allows us to have the same robust configuration in the pocket, but to tilt the insert less negatively than other designs. Less negative means more positive. More positive means softer cutting. As an example, you can see some of the designs in the marketplace. On the left is the Ceratizit design, and you can see that the difference in the axial tip angle is significant, maybe 7 degrees. So this allows us to create a more softer cutting action. It also has the benefit of allowing us to build insert rake angles that are lower than other designs, meaning more stable in the pocket and adding some robustness to that insert design.
All right. So next question, what would you say to a shop hesitant to increase its feed rate while using a double-sided high feed insert?
Well, I would say get out your calculator. high feed cutter designs have a unique theory to how they are able to create higher metal removal rates. It's simple. You change the approach angle. And when you do that, you thin the chip. As illustrated in the diagram, you can see that a 90-degree cutter has a thick average chip thickness. When you tilt the approach angle, the chip thins. So, given that an insert has a particular average chip thickness that it likes to operate in, if you've taken the approach angle down from 90 degrees to, say, 15 degrees, you've thinned that chip maybe by 80%. So to get back to that average chip thickness that that insert would like to see, you need to accelerate your feed rate, say, 5 times. So when you look at that, you realize that when you increase your feed rate 5 times, you increase your metal removal rate 5 times. Here's a good example. On the left is a conventional set of data for a milling system that is not high feed. And then on the right, you see a milling system that is high feed. So if you look at the values, you can see that at moderate to medium depths of cut, you're anywhere from 3 to 5 times the feed rate for a high feed system. This is significant. In many cases, this is going to be significantly higher metal removal rates than conventional systems. But you would have to do the calculation. And basically it comes down to what that metal removal rate actually is. So it's the width of cut times the depth of cut times your feed rate in inches per minute. So for a conventional system to compete with a high feed system, it would have to be able to take theoretically a depth of cut that was 3 to 5 times the average that that you're comparing to. So now you can see why high feed systems are so productive. And really, at the end of the day, it is about productivity, because the cost of tooling is maybe 3 to 5% of the total manufacturing cost. So what's really important is how quickly can you machine a part. So you're going to look at high feed milling systems as your roughers or your medium machine go-to type cutters. And then you're going to have to come back through and come in with some finishing cutters to, say, clean up the corners of the pockets and whatnot. So this is one of the main features of the high feed systems. Very high metal removal rates.
Before a shop decides to use these types of inserts to increase production efficiency, are there any other factors they need to take into consideration?
Yes, actually, there are a couple things to think about. First of all, pay close attention to the depth of cut, the maximum depth of cut that cutter and insert are allowed to take, because it's designed to high feed on a 14-degree approach angle. But once you round that nose radius, now you're not at 14 degrees anymore, and you cannot high feed past that limit. Otherwise, you'll break all the inserts. So pay close attention to what the max depth of cut is for that particular insert and cutter. Second of all, horsepower. So now you've adopted a high feed system, and you see that now you can get 20, 30, 40% more metal removal rate. You're also going to need more horsepower, because horsepower is your metal removal rate times a power factor. Now, power factor basically equates to the machinability of a material. So something soft like aluminum might be power factor of 0.3. Something much harder like Inconel or titanium might be something like 5.4. You know, I'm just making these up. But comparatively speaking, the power factor then is multiplied, and it gives you your estimated horsepower requirement. So if you're running at higher metal removal rates, you're going to need more horsepower at the spindle to run that cutter. Also, think about horsepower and torque. And if you look at most modern machines, they run with, for the most part, constant torque, but horsepower is a function of RPM. So if you are running a large diameter cutter, you may not be able to generate the horsepower required to run that larger cutter. So in some cases, you may have to go with a small diameter cutter that you can run at higher RPMs to get the horsepower up where it needs to be to run that cutter, because some equipment is not going to have enough power at the spindle to run these larger size cutters. So be very aware of that. Also recognize that these high feed systems have forces that are mostly directed, cutting forces that are mostly directed axially up through the axis of the tool towards the spindle. So they are gentle on the spindle, but they also are not going to generate a lot of chatter. So they're very useful for long reach face milling. So if you have a deep pocket and you need to get a shank style tool down in there, high feed system is going to be very forgiving when it comes to machining that material.
Unmute myself. So now we're going to start taking questions from the audience. And to get that rolling, I just want to make sure that everyone knows where that's going to be. It should be somewhere up here in the corner of your screen. You can submit a question, and when you submit something, you do have a choice to submit it anonymously if you want. Just check that anonymous button and it'll be submitted anonymously. And if you want, if you see a question that shows up in to the right of your screen and you like the question, you can click it that you like it, and the more popular questions we will give more, we'll be quicker to post them so that we can answer them here for everyone. And we will display the questions on the screen once they come in. You know, if no one else has a question right now, I want to add Keith Jennings to the to our program. He's our guest moderator. So I'm gonna.
Okay.
Hey, Keith. Keith, you want to introduce yourself? Keith is. I'll just tell everyone. Keith Jennings is a former, or in the past, has written our Machinist Corner column for Cutting Tool Engineering magazine, and he owned and was president of the Crow Corporation down in Texas for many years, and recently sold the business. And so hopefully we'll be working with Keith a little bit more here on in Ask the Experts webinars. So with that, Keith, you just saw the presentation so far, and as soon as any questions come in, we'll start answering those for our audience.
Okay.
So do you, as you were looking at it, have you, what's your experience with double-sided high feed inserts?
We had some equipment of that caliber. So we experimented with that too off and on, and as has been described and talked about in some material in CTE from Mr. Richter and Rob, and the coordination and relationship between our shop as the end user and tooling companies and vendors was a huge resource and help. And that became a big factor in that, just trying to upgrade and or experiment with some of this new technology and new things. And again, it did over time, we did lean on them more too. So I haven't had to buy any lately. So if some of this had been kind of updated information even to myself, and I still work or help them a little bit, but I did find it interesting that just that relationship and how that's kind of expanded more and more. And I did want to ask Rob that too, if he was himself getting those type of requests or had that opportunity to do that, or was that more of a local vendor? I'm not exactly sure how his chain is working, but I did find that important and helpful for our shop. And we had a really good group of guys who were very knowledgeable, so I could rely on them and lean on them. And they would work with the guys and gentlemen like Rob figuring this type of stuff out. It just depended on what type of product we were making. Some stuff would be prototype or test type of products first, and sometimes it would develop into longer term relationship or product line that you would in fact need to perfect and develop this type of technology. Sometimes it did not, but that's just part of the whole process. But anyway, I did find it interesting how that's evolved over time, and was wondering about that with Rob too, if he himself has to get involved in things like that or interface directly with some of the shops like us, or if that's more of a local thing through his supply chain, or how that's working, because I still know numerous shops down here, and I think they would find this interesting and know, kind of how that's changing and perhaps who's open to working with more.
Well, it's two-tiered. Obviously, our company has a great group of guys in the field, and their responsibility is to bring this technology to companies like yours. And I do get a number of questions as a product manager from customers who call me and say, hey, trying to figure out how to do this, or put together tooling for this part, or tell me what the feeds and speeds are for this particular cutter system. So I get questions like that, but I obviously have to rely on our talented sales force to get out there and push it.
Understand that. Well, I can again validate that, and it helped us a lot on having those relationships like that. That was a big part of our success, and it's just interesting to see how it's changing over time. We used to have a poster in our office that had a light bulb on it, and it had a statement in quotes underneath the light bulb that said, from 1899, everything that could possibly be invented has been invented, and life is about as good as it's going to get. And guess what? We're still talking about this stuff getting better and better every single day. And it's just an interesting technology and stuff to follow. Again, I haven't had to buy any lately or have those meetings in the recent past, but did it for many, many years. And again, I enjoy passing this type of stuff on and working with other guys that I know and people in shops and companies that are trying to do this exact same thing, because I'm a huge supporter of that, and making it here, making it local, and helping people get smarter and better with stuff. And companies like y'all and Rob are helping make that happen too, all the way down to the bottom, and it's awesome.
So we do have a question that has come in. I'm just going to go ahead and show it on the screen. Rob, if you want to comment on, it's from one of our viewers, Chuck, just wondering about whether the cutter holder diameter size is at all a factor.
Obviously, because these systems, the high feed systems, require more horsepower, you're going to want to use the largest sized adapter you can to build the most robust connection to your machine. So, but typically the machine is going to predict what holder type you're going to choose. So in that case, then you may have to deal with the diameter of the cutter itself, in terms of getting the RPMs where it needs to be to run the horsepower that you need to generate to perform that particular set of cuts, based on whatever the depth of cut is, feed rate, material type. I think that's answering this question. I'm not sure.
Well, if it's not exactly what Chuck was getting at, Chuck, if you want to follow up with a question, if that didn't answer what you were looking for, just let us know. You can submit another question. Meanwhile, one of the things that I wanted to just touch on was, is this aspect of the experts in the field at these companies. By the way, Chuck just said that was the answer he was looking for. So good. So one of the things that's taking place, and by the way, this whole webinar is sort of based on the feature in our April issue about these indexable inserts, and one of the sidebars to that article is really about the role that companies are taking on for shops around the country, which is to be kind of the expert and provide some guidance on improving production efficiencies at shops, because the way the staffing is going throughout the country, according to the article, is that the shops don't have as many staff members who might be able to spend the time to focus on improving production efficiency on the shop floor. So I'm wondering, Keith and Rob, can you speak to how great a role that is, and maybe that's one of the reasons why this expert excuse me, Ask the Experts series may be useful. But can you speak to the trend, Keith, if you wouldn't mind?
Well, like I said, I know over time, as we upgraded equipment and took on different projects and work, those things would come up, and sometimes it would be economical or worth the ROI, and sometimes it may not be, depending on the customer and their market. But it was a learning process along the way as we experimented with new equipment and adding things. So I think there's, even since I've had to make parts, there's some technology and things that have evolved and been updated even since then. It's amazing to see. I haven't had to go get a demo lately, but anyway, I know that we were always interested in that. And again, sometimes it made sense, sometimes it did not. But we were looking at it also from a big picture, and of course, budget and other factors, and time, money. But sometimes, yes, it made sense, and we invested in stuff like that and experimented with some stuff like that. And companies like Rob's company, we weren't an exact client of them, so I'm glad to know about them. But we did receive lots of guidance and help like that, and it helped us progress.
Okay. Rob, what about you? Are you getting more calls? Are you finding that you're consulting more over the last several years? Is it something that, can you provide some perspective on whether this is a real trend or not?
Well, it's gotten really busy in the last half year to year. I think most companies probably are now past the COVID recession, and of course we all know about supply chain issues and whatnot, and worker shortages and whatnot. And I certainly, the number of calls, the number of questions from customers and distributors has gone way up. And of course, it's our obligation as tooling manufacturers to figure out how to get our technology and the knowledge about our technology to the marketplace. And events like this are one way. Obviously, all the marketing tools that multimedia provides is another, clearly. But we often find that when you get into the shops and you have a chance to talk to guys on the floor and to the engineers, you discover that there are lots and lots of misapplications, the wrong style of cutter or the wrong machining conditions. And usually customers do not maximize the potential of the tooling systems that are in place in their shops. Like we said before in this presentation, some machinists were afraid to use all the insert edges. Tooling manufacturers looked at that and said, we can solve that problem. But it's incumbent on us to get into the field, get into the customer and say, what are you doing? What are your problems? How can we be solution providers? And in many cases, you can look at even existing conditions and say, hey, we can really do a lot here for you. With a gentle touch, because people don't like to be told they're not doing things correctly. So you have to be, thoughtful about it and informative about it. I think we're constantly seeing that and constantly working to try to help manufacturers become better, produce parts more quickly, make more money, be more profitable. And that's really what, in this particular case, the HiFi systems really do for us. For customers who have a lot of material to remove, applications where you have got, these roughing applications where you've just got lots of material, maybe, high volume series of parts, that cutter system is absolutely ideal for that scenario. But for smaller shops, for example, maybe they need a pause system just because they want it to be able to ramp and plunge and do other things that these double negative insert designs cannot. So it depends on what the customer is doing, and that's really on us to help them at least be more aware of what's available in terms of tooling technology.
Mm-hmm. Very good, and it really does seem like if a shop is out there and they've been doing something a certain way and it's been working just fine for them, whether it's not necessarily doing something wrong or the wrong way, but maybe they're just not aware of the newer technology that may help them make a slight adjustment or use a different tool to increase their production and basically the bottom line. It is interesting to me the cost for the tool itself. Rob, you want to touch on that again? I mean, because that to me is it's interesting. It's such a low portion of the cost in the whole process.
Yeah, I think when we go into a shop and we can make improvements in productivity, frankly, the tools pay for themselves. The tools are free because you make a lot more money and profit, machining 100 parts and getting them out the door than you are machining, say, 60. So, if you're concerned about tooling costs, that's fine. And that's important. But what really is most important is how do you become more productive? How do you make more dollars per hour? How do you make your men work smarter and build parts more quickly?
Was that ever an issue for you, Keith?
Yeah, it was actually at times. I mean, we had over the years, we had very experienced machinists and employees that, we got a system, we have it set up, it's, making some profit on it. And so why fix it if it's not broke? But sometimes we get introduced to some new technology or something, and you got to be able to go out there sometimes and take a stab at it and experiment with it, and sometimes override that and look forward in a way. Yeah, it is working. We're profitable on it, but can it be even better, safer, faster? And that happens. And we were always willing to at least look at it and experiment, and at least evaluate the matter. Like I said earlier, sometimes it made sense and sometimes it maybe wasn't the right time. But that was another question I had for Rob. Is there any noticeable, at this point in time, at least stuff change? I mean, pricing and stuff gets better, usually moderates over time. But is this investment in convincing shops to use it more and more? Is it require a higher investment that they're sometimes reluctant to? Or do you get feedback like that? Or is it pretty cost competitive or coming down or close to, the old way or what we've had? I mean, does that factor inhibit in any way the potential progression of this and market share of this?
Yeah, I mean, you're not going to probably sell the cutter unless you can come in with a test report that says, here's what we did, here's how many pieces we got, here's how much faster we ran, and based on your machine time per hour, here's how much money you saved. We saved you $15,000 a year. Cutter bodies, $500. It should be a no-brainer.
Right, exactly. Yeah.
So I think you have to do your homework. You have to prove it to the customer because, like they say, I'm from Missouri, show me. And
Right.
That's perfectly fair. And we are obligated to do that, and we should do that. And I think once you do that, customers go, yeah, I can see that.
Understand. Yeah. Had that experience. And is it most of this, Rob, is it pretty universally as far as brands of equipment go? I guess it's adaptable to most brands of equipment that have that technology, I'm assuming, right? There's no particular version. I mean, companies or brands that you would avoid and say, no, we're not going to work well with that.
No, no matter what kind of equipment you have, you can figure out a way to make these new technologies work.
Okay.
Right? I mean, again, like we talked about earlier, you may have to choose smaller diameters where you can get RPMs up, so you can generate more horsepower, so you can actually perform that metal removal rate. But even light duty machines, you may have to adjust your machining parameters. You may have to, like I said, use smaller tooling. But there's no reason why virtually any machine can't take advantage of these tools. I mean, we do build some larger high feed systems, and if you fully engage those systems, you're going to need 50 horsepower with the spindle to use that cutter. But there are plenty of other options depending on your your depth of cut, your radial depth of cut, and your feed rate. So, and of course, there's so many factors, right? What grade of carbide are you using? So how fast can you machine that? Harder grades of carbide, you can run faster, so you can again become more productive in that way, as long as the operation allows for it. Maybe something that's a continuous cut, something no interruptions, no nasty material, whatever. So, but there's always a way to for a good tooling engineer, there's always a way to find a reasonably optimized solution.
I understand. Okay, good.
Well, I'm gonna just jump in here just to see if the audience, this is the time to submit any questions. There are no other questions submitted as of this moment, but if anyone does have a question, just go ahead and submit it. We'll give it another minute or so to see if anything comes in. Meanwhile, I want to take the opportunity to thank Rob and Keith for taking the time, especially Rob. All the effort you've put into the webinar. I think we provided some good information, and I can't thank you enough for the rehearsals that we went through to get this together. So I appreciate that.
Yeah, thank you, Dennis. It was a great it was a great chance to connect with the your team and the audience out there that is curious about this technology. It's a pleasure to be able to do this.
Mm-hmm.
Looks like we do have one question that just came in. Hang on. Let me show that. So, can you see that, Rob? It's can we use this for roughing milling operation PCBN insert? 3 to 4 millimeters.
We don't offer a CBN insert with our systems. Theoretically, if we did, and you were machining, say, cast iron, I don't see any reason why you couldn't. We don't offer that option, but I'm assuming that we're talking about cast iron. But 3 to 4 millimeter depth of cut, again, it would depend on the insert size whether you could do it. But if you were to pick our largest insert size, the size 19 in the high feed system, this is a positive system, so it's not a double negative. That can take 130 thousandths. So theoretically, if we had that tipped with CBN, then yeah, you could do it. But it's in our particular case, it doesn't exist.
Okay. Well, Keith, do you have anything else, or Rob, do you have anything else you'd like to add to close us out?
Thanks for having us.
You're muted, I think.
Okay.
Yeah.
No, it was very interesting. I'm glad to be able to do it and be here and share this, experience with y'all. And one thing I was thinking about before we close it out, with kind of the Russia-Ukraine conflict and whatnot, and I know a lot of machine tools are sold in that part of the world. Is there any concern going forward about that, and any issues as far as market and economy and things that y'all are seeing coming up in the next year or so, or the rest of this year, or do you still look pretty solid? I don't know how much that could impact. I know a lot of machine tools and machining equipment are sold in that part of the world, and it looks to be generating some concern in the world, in markets in some ways, but I'm not totally sure if that's totally accurate or impacting companies like y'all or not. I'm just curious about that. If you were having any feedback or any global type of market concerns coming up.
Rob, do you have anything on that?
Well, I don't call in the OEM, so I don't really have a sense for.
I didn't know if y'all may sell and do much business over there too, or what. I'm just.
Oh yeah, yes, okay. We do.
I figured you did.
Very dominant player in Europe. But again, I'm more regionally oriented. So
right, I got you.
I'm not sure I can really fairly answer the question. All I can say is we're pretty darn busy right now, and I don't see that letting up in the near future, despite the Ukraine conflict. Doesn't seem to, at least so far, had any effect on our revenues or our ability to get product to the marketplace.
Okay.
It really hasn't affected our supply chain because we're vertically integrated. So we manufacture all our own piloters. We control every aspect of our production process. So,
okay.
And that's maybe we're one of very few tooling manufacturers that can say that. So it's to have the protection of owning your own mines and having that security, not having to rely on a global supply chain for material.
Okay.
So in our case, it hasn't had an effect, at least not that I can see so far.
Okay, interesting. No, interesting. Okay, I appreciate you sharing that. I didn't totally know all that myself, how y'all were set up.
Yeah, I can't speak to other manufacturers, but
no, I understand. I got you. Sounds great.
Okay, well, at this point, I think we'll end the Q&A session. I'm gonna, before we end the session completely, I want to display our contact information for anyone who might want to reach out to Rob afterwards. His email address is right there, robert.bokram@ceratizit.com. My email address is also there, dspaith@ctmedia.com. I'll leave that on the screen for a few minutes once we close this out. But I want to, again, thank everyone for participating in this and taking some time to and learn about this subject. We do have a couple of more Ask the Experts webinars coming up this year. The next one is in July, and then I believe the final one of the year is in October, I think. Look for those dates on our website in the webinar area under our video tab, video reports tab of our website. Again, thanks a lot for attending. If anyone else has a question that they'd like to ask afterward, they can submit it to either me or Rob directly if they'd like. Rob?
Just a quick question: Is this a feed? I mean, I think you've recorded the whole thing. Is this something that is available to the audience that attended? Is it a downloadable document, so to speak?
Right, and once we're finished with today's webinar, it is being recorded, so the whole event will be available on demand whenever someone wants to come back and watch it. Or if somebody who signed up for this event, which we had just about 80 people signed up, they can watch it at their leisure. It won't be live, obviously, but so yeah, all these webinars that we're doing are recorded and will be available whenever anyone wants to watch them through our website, and we can embed it on the Ceratizit website if you'd like. It can be streamed wherever through our Vimeo video channel.
Yeah, good to know. Good, thank you.
Yeah. So yeah, we are finishing up early for this session, and unless there's anything else from anyone, again thank you. Here's I'm just going to leave this up when we say goodbye. If you want to grab those email address and that contact information, you're welcome to it. Thanks again.
Thank guys.
See ya.
See you, Rob. Thanks.
All right.